This is example 7 in lesson 3-4, where we're told that the area of a square is 3 times its perimeter. Find the length of a side of the square. So I decided to make my square with sides of length S. Of course, they all have to be S because that's what makes it a square. All the sides are the same length and all the angles in the corners are right angles. So we're comparing perimeter to area. Perimeter is just distance around. And so we can find the distance around by just adding up all of those sides together. So we're basically just adding 4 S's together, which makes our perimeter equal to 4S. The area of a square is found by multiplying length times width. So in this case, that would be S times S. And so the area of our square would be S squared. So now back to the statement, area is 3 times the perimeter. So area can be replaced with S squared, and then that perimeter that we got of 4S needs to be multiplied by 3. And now we have an equation. We're going to need to solve for S. So we'll have S squared is equal to 12S. And the best way to do this would be to get it equal to 0, so we can use that same property we used in example 6. So I'm going to subtract 12S from both sides. I've got to remember like terms here. S squared and 12S are not like terms, so they cannot be combined as 1. So I'll just have to leave it S squared minus 12S. And now there's nothing left on the other side, so it equals 0. And now it looks very much like example 6. We want to solve by factoring. We notice that the greatest common factor is S. So again, I'm undistributing. I'm going to put that S out in front. S squared divided by S to the first is S. Negative 12S divided by S, those S's cancel, and I'm left with just negative 12. So once again, I have two things, A and B, that are multiplied together, and their product is 0. So if either one of those was 0, then we would have a true sentence. So we take the A part and we set it equal to 0. So one value of S is 0. But in this case, that's not reasonable, because a square cannot have a side of length 0. The square wouldn't exist. So practically speaking, that's not a solution. But the other value, B, in this case S minus 12, should be set equal to 0 as well. And when we add 12 to both sides, we find the length of the side of the square would be 12 units. That is a reasonable answer. And so now if we go back to this original equation here that we set up and we replace our S with 12, we'll have 12 squared is equal to 3 times 4 times 12. Well, 12 squared is 144. 3 times 4 times 12 is also 144. So our solution works. The side of the square is in fact 12 units long.